More than 2.2 billion tons of waste are generated worldwide every year, and paper accounts for nearly 26% of that total, making it the most common type of trash on the planet. To put that into perspective, the amount of paper thrown away each year could cover millions of football fields. But here's the good news. Paper can be recycled up to 7 times before it becomes unusable. So how does that recycling process actually work? Join me inside one of the largest paper recycling plants in the United States, where hundreds of tons of old paper are reborn every single day, transformed into smooth, bright white rolls of toilet paper, ready for everyday use. Let's dive in. Thanks to modern recycling technology, paper that once seemed to have lost all value, such as invoices, old newspapers, or discarded cardboard boxes, can be given a new life. These materials are carefully cleaned, thoroughly processed, and transformed into fresh, bright white rolls, ready to serve an essential purpose in our daily lives, all without paying a heavy price with our forests. Before it becomes a soft roll sitting in your bathroom, toilet paper begins its journey in the trash. Each morning, recycling trucks make their rounds through local neighborhoods. Using mechanical arms, they gently lift the bins and load every piece of used paper into the back compartment. The entire process is carried out smoothly and efficiently, with careful coordination, marking the beginning of a thoughtfully managed recycling cycle. The convoy of garbage trucks then heads toward the sorting facility, a plant that plays a crucial role in handling waste collected from surrounding communities. Here, an average of 500 tons of trash is sorted every day. Among the piles, used paper is separated from mixed materials like plastic, metal, or glass, preparing it for the next stage of its transformation from something once considered useless into a valuable resource. Once collected, recycled paper is rarely clean. It's mixed with all kinds of impurities: nylon, bits of plastic, small metal scraps, and even leftover food. All of it is dumped onto a long conveyor belt that carries the waste into the sorting area. There, waste workers quickly pick out pieces of nylon and other unwanted materials by hand, keeping only old newspapers and printed sheets that are still clean enough to reuse. Because they work in direct contact with the waste throughout their shifts, they always wear proper protective gear, including face masks, rubber gloves, and safety goggles. After manual sorting, the paper is fed into a vibrating material separator, a key piece of equipment that performs an initial filtering of the mixed input. As the materials spread across the surface of the machine, constant mechanical vibrations cause the lighter paper pieces to move forward, while heavier materials like cardboard, plastic, or small metal fragments fall through below. Thanks to this continuous vibration, the remaining impurities are removed, leaving only paper to continue its journey along the conveyor belt. On average, each person uses roughly 100 rolls every year. The sorting process doesn't stop there. Recycled paper continues its journey to a specialized device called an air separator, where powerful wind currents work together with advanced optical sensors to perform the final filtering stage. As the materials move along the conveyor belt, the system automatically scans and identifies lightweight objects that aren't paper, such as plastic bags, film wrappers, or soft packaging. In an instant, high-pressure air jets are activated, blowing these unwanted items off the line. In some of the most advanced facilities, the sorting system has been fully automated using robots equipped with computer vision. These robotic arms can accurately identify each type of waste based on its shape, material, and color, then pick it up with precision and place it into the correct bin. Thanks to this cutting-edge technology, the need for manual labor is significantly reduced, while both the accuracy and speed of the sorting process improve dramatically. This not only boosts overall efficiency, but also allows the system to handle much larger volumes of waste without compromising quality. The selected paper is fed into an industrial shredder where rotating metal blades tear it apart non-stop, reducing each sheet into thin strips. These shredded pieces are then piled into large heaps, waiting to move on to the next stage: baling. A bulldozer advances and pushes the piles of shredded paper into the pressing chamber. Inside, the paper is tightly compacted into neat, square blocks, almost like recycled bricks. A forklift then loads the finished bales onto trucks, ready to begin a new journey, this time toward the toilet paper factory. There, the shredded paper, once baled, is quickly transported to the toilet paper factory. A forklift carefully places each block of paper in the raw materials receiving area. Just one 800-kilogram bale can produce over 10,000 rolls of toilet paper, an impressive number by any standard. Once inside the factory, the shredded paper is fed into a pulper, the machine where the breakdown process begins. Here, the paper is thoroughly mixed with water in massive tanks, usually at a ratio of 1 part paper to 10 parts water. At the bottom, a high-powered agitator runs continuously at speeds between 1,000 and a few thousand RPM, creating a strong swirling motion that separates each cellulose fiber. Depending on the size of the system, each pulper can process anywhere from 2 to 10 tons of paper per batch. This stage is absolutely crucial for producing a pulp that's fine, clean, and uniform, the foundation for the quality of every finished roll. During the pulping process, the mixture isn't just stirred, it's also treated with specialized chemicals, including dispersing agents and de-inking compounds. These additives play a crucial role in thoroughly removing leftover printing ink, adhesives, and surface coatings from used paper. Thanks to the continuous and vigorous agitation, the slurry becomes progressively finer and more refined. As the cellulose fibers are fully separated, they begin to intertwine and bond together through natural hydrogen links, an automatic process that forms the basic structure of the new sheet of paper. The mixture then transforms from a liquid dispersed state into a uniform structure ready to be formed into new sheets of paper. This entire process typically takes between 30 and 60 minutes, depending on the quality of the raw materials and the specifications of the final product. After the pulping process, the resulting mixture still contains up to 95% water. To continue building and strengthening the thickness of the material, the slurry is transferred to the dewatering system. There, the pulp goes through rotary drum machines, where large metal cylinders spin continuously, causing the pulp to adhere to a mesh as it rotates. Excess water is directed to a recovery system located below. As a result, a thicker, moist, and flexible layer of pulp is formed, ready to move on to the pressing and forming stage. After removing a good portion of the water, the damp pulp layer moves into the pressing and forming system. At this stage, the pulp is fed between large steel rollers covered with a fine mesh. These rollers rotate in opposite directions under high pressure. Their job isn't just to shape the paper's width, they also work to squeeze out even more moisture from the material, helping the sheet become flatter, more consistent, and reach the standard thickness of around 15 to 20 microns per layer. With steady, evenly applied pressure and a precisely controlled operating speed, the pulp slowly begins to transform into a continuous paper sheet, still uncut at this point. Even though the whole process only takes a few seconds, it plays a vital role in giving the paper its mechanical strength and making sure the final roll is uniform, durable, and meets production standards. After being formed, the thin paper sheets go through a calendaring system where the surface is smoothed and the shine is enhanced. From there, the paper is rolled into massive reels with diameters of over 1 meter.